right? How many of you have not ever used SPSS? Is there anyone जिन्होंने SPSS कभी use ही नहीं किया in the audience? Can you hear me? Can you tell me so that accordingly I'll share related to this? Right? Is there anyone who has never used SPSS?
Yes.
All have used?
No,
huh?
I have not used SPSS.
Okay. So you'll be using for the first time?
Yes.
Okay, not an issue. But have you installed SPSS in your laptop?
Yeah, I don't have SPSS. I cannot work on that. I downloaded from website, but I don't have a right to execute data over it.
Oh, okay. So in that case, my suggestion would be yes, जब आप participate करेंगे तो probably will all be benefit, and there might be some more जिनके पास नहीं है. So on screen I'm showing you download SPSS, right? You go to this website, IBM SPSS trials, right? If you go to this website, IBM SPSS, try SPSS statistic at no cost, right? If you click it, it will take you to this link where you'll have to create your free trial account, your email, name, some password you'll have to choose, then some more information, and next window it will ask you for your mobile number. It will register you, then it will allow you to download. And once you install it, you can use it for 1 month. It will be free for 1 month, right?
Okay, sir, thanks.
Then this is also a similar version which I'm sharing right now on this system. So it will look like this once you open it. And later on, you can also have, access from your friends or colleagues where they have cracked version or some other sort of version which is usable for always. So later on, you can try that, right? Once we have SPSS open, it has data view and variable view, right? And quickly coming to how to import data from Excel. So you go to File and then import data or open data file. Both ways is possible. So imported Excel file, right? You have, I think the files with you. All have the files. Did you receive all the files I have shared?
Yes.
Okay. So in that right now, I'm using this file, mutual funds itself, right? This is an Excel file. If we open it, the first file, okay, it will not open till the time that Excel file is closed, right? So you'll have to, I'm not saving anything in this. So this is the file that should be closed, okay? So close that file and reopen it through Excel. Now, sorry, reopen it through SPSS. If you do that, it will ask you which sheet you want to, worksheet you want to open. So we'll ask worksheet 1 itself because it has more worksheets. So let's open worksheet 1 itself. If you do that, it will accept your instructions and it will open like this. Those who have SPSS can open it in it, right? And then once you open it, if you go to the variable view, and this is important, the measures that we have discussed, right? Whether they're nominal, ordinal, interval ratio. Nominal, it will show like a this Venn diagram shape, and scale, it will show as a scale, the measurable scale. That picture will be visible along with it. And then for ordinal कुछ था हमारे पास में. Let's see if we make that ordinal. I think category can be ordinal, right? Category में this was large cap, small cap, mid cap. So ordinal would be like a histogram, right? That would be ordinal data. Objective is nominal. We discussed that, na? And then assets were scale, fee was nominal, and risk was also. Risk भी कह सकते हैं would be ordinal, right? So this kind of view you would be having. So once you have it, then next stage can be, you can think of its analysis, or even think of its missing values, right? And how you can handle those missing values and data. So before actually we go to the analysis and interpretation, let's try to further understand the outliers, right? If there are any. So to be specific on outliers, we'll go to chart builder. Under chart builder, say OK, and the method used for identifying outliers is box plot, right? If you want to identify one by one, so you'll have to shift this under box plot. If you are able to reach till this, shift this box plot here. So whatever in this window, and say you want to check for return 2006, right? If you do it and then say OK, so it will help you the idea of your outlier visually, right? So it will show the results like this, and it's quite possible that some might not be aware of box plot. So before we actually interpret this, let's have an idea of what is a box plot and how do we apply that here. मैंने थोड़ा सा बीच में jump किया था, reason being because time is limited. I thought you should get the benefit of some analysis and data handling also. इस पे आते हैं missing पे दोबारा से. I'll take you to the box plot, right? Box plot is related to 5-point number summary, which is quite an important concept. 5-point number summary that help you describe your data. So what is the smallest value? What is the first quartile? Anyone who is not clear about quartile, I hope all are aware of quartiles. These are 3 points which divide the total data into 4 equal parts, quartiles, Q1, Q2, Q3. So if you have 3 points, data would be divided into 4 equal parts. And then largest, right? Like in this case, Q1 is first quartile, Q2 is midpoint, Q3 is third quartile, and you have 25% of the data everywhere. This is a graphical representation of data. And to further understand this, we can have, if it is symmetric, you'll see the box plot visual as like this, as for a normal data, right? If it is right skewed, you'll have right tail extended. If it is left skewed, you'll have left tail extended. And then again, rightly skewed data, if you have more, skewed values on the right. This we discussed. इसमें हम एक out, this is the identification. How this box plot is made. It does not take that exact minimum value. How these points are decided, lower limit, upper limit, and you would see some points lying outside the box plot area. Here is the box plot area. In between Q1 and Q3 is the IQR interquartile range. And then maximum is assumed as 1.5 times IQR, right? 1.5 times interquartile range. This will consider the upper limit. 1.5 times IQR, this will consider as a minimum limit. And outside these values are considered as outliers, and then those can be dealt with, right? So we'll have values in this format. जो इससे बाहर lie करेंगी, these are outliers on the positive side, upper side, and maximum side, and then you can have some on the lower side as well. So let's look at our results. So we had these results of box plot of 2006, right? The benefit with the SPSS is you can copy paste this simply. जब भी ज़रूरत पड़े, you just copy it and paste it to your analysis part, and otherwise you can have this button here, which can help you export all these results together into a Word document or PDF or PPT format, and then those can be used along with its some people are waiting in the lobby also, is it? I don't know. Harshita, you can check that.
Sir, I joined them. I admitted them.
Okay. Box plot. So here you see now in 2006, it says 797. What does this mean? It means the value 797 is the extreme values. In this case, these are on the lower side. So let's have a look at what is this value 797. तो इसमें अगर आप देखते हैं, if you just go it in 2006, 797 value number. Yeah, this value, and under this, right? Okay, ये वापस चला गया. $797 serial number. So the value is 35, which is, I think, quite large in comparison to other returns, 19, 28, or 15, right? So this is on the higher side, and then again you can identify the other outliers, right? So this way you can identify outliers, and for some more also you can build the box plot, right? If you do it for 5-year return, so 5-year return box plot is this. It has more, values outlier. Those can be identified. Once these are identified, you can deal with them. Okay. So this is about outliers related to missing values. If you have missing values in your data, how do you deal with missing values? This would be list-wise deletion. If for some particular question, right, nobody has responded, or only 5%, 7% people have responded. Sorry. So it's better to, rethink of that question, or replace or delete that question. Or there's some respondent who has not given his viewpoints, and all the values are blank. So for that particular, say serial number 9, you can remove that completely. This comes under list-wise deletion. Pair-wise, suppose for question number 5, the respondent number 10 has not given the value. Remaining all values are available, so only that particular value can be removed. So this will save your data if you are going for pair-wise deletion. Replacement, you can replace the missing values with some estimates. This could be mean, or this could be median, or nearest value. That these are some ways of handling missing data, right? And when you come to its analysis, but before that, let's also take another example of data in terms of, say, if we have a panel data, right? And one more thing probably could be useful here if you're talking about data itself. Suppose some of you, do a copy paste of your data. Suppose this is copied, and then you paste it in your own data in a shuffled manner, and you try to increase that data, right? So that can be identified here in terms of data. You can identify duplicate cases, right? Duplicate cases with the help of some of the variables. If you repeat it, say define matching cases, and then say OK. So this will help you identify. Suppose यहाँ पे आपको ये summary table आ जाएगी. So there are 16 duplicate cases, 1.8%, right, which are repeated totally. And so it's 1.8% duplicate cases. And if you go to data, it will show you which cases are duplicate, right? So it has created one column here automatically. And here you have some cases as duplicate, some as 1010 you show karega. Okay. So cases with 0 are duplicate cases. One is the original case, right? So that way this can be identified, right? So those can be removed hence. And to understand some more type of data, let's open another data file now. Do you have split bank data? Can you open it? Split bank data is an SPSS file, and it will look like this. Okay, it's a sort of panel data where you have data for year 1999, 2000, 2001, 2, 3, so 99 to 2003, and data is of public bank. You have data of private bank and foreign bank. This data is based on this cash deposit ratio, net interest margin, return on equity, cost of deposit, cost of borrowing, cost of funds, borrowing per employee, profit per employee, such kind of data we have. So it's quite possible when you deal with such kind of data, and at a time you have to have the results. If you calculate the results, now let's say let's now enter into analysis part of it. So in the analysis part, you can begin with descriptive statistics. And if there is a categorical data, because whatever we have learned, we should apply it rightly. Categorical data should be used for frequency, uski frequencies banengi, and numeric data would be used for descriptives. So under frequency, you can have categorical data, right? Year, type, and only two are categorical. Display frequency table. In statistics, it will not make sense of calculating mean, so categorical mean mode itself is enough, and that's it. Or chart में भी आप चाहें तो you can have histogram, or you can have bar chart, or you can have pie chart, right? Okay. You can change it as per requirement. If you do that, you have this data. To understand the data, data is of these years, 99, 2000, 2001, 2, 3. Frequency you have, percentage, valid percentage, and bank wise, if you say, public bank 132 banks, private 147, foreign. So this is your summary of descriptives. Then you have pie chart. So this is about the categorical data, right? When you have to do it for the numeric data, so for numeric data, you transfer from left pan. You may call it as the left pan and right pan. So whatever analysis you have to do, those who are doing it for the first time in SPSS, you transfer. Now these are scale variables to the right pan, right? You can relate it with kitchen. जिसका भी तड़का लगाना है आपको उस pan में तो डालना पड़ेगा ना, which is on the burner, right? And then in the options, when you see, you have mean, standard deviation, variance, range, then skewness, kurtosis. You can say OK, and then style would be, as of now we are not using it. Say OK. When you do that, you'll have these results, right? But these are results are of in total, right? In total of all the variables together. We do not have what is happening in any idea of what is happening in 99, what is happening in one bank or the other bank. So if you want to have results year-wise, bank-wise, then that option is there, which would be more useful for us. For that, we go to data, and under data, we split the files, right? Split into files. How do we do that? Split files, we can say split files by year, split files by type as well as हमें दोनों का चाहिए, and then I think that is sufficient. इसमें options देख सकते हैं आप. Output file name based on split file variables. It's okay. So say okay, right? Somewhere it has a missing or invalid value. Let's see क्या हुआ इसमें. Analyze when you do the descriptives. This time with all the similar results. So अभी split नहीं हुई है. Let's check. Split file. Compare groups. Under compare groups, you have year and type. Okay. Use this split file. Okay. इसको दोबारा से show करता हूँ. Split. अच्छा, split into files नहीं. Just use split file. Huh? There was an error there. We'll be using this. Compare into groups. Year by type. Simply say OK. So now showing that it's ready. Then now there is no error. When you do the analysis, then in frequency भी check कर सकते हैं आप जो आपने किया है. Same you may say okay. So this will give you the results of statistics. Now year-wise it is coming of categorical data, and then type. ये सब results आ रहे हैं आपके पास में. Pie chart year-wise. Some may be useful, some may not be useful, right? But you have the results, right? Then in case of frequency descriptors, you have the results for the data. So you will get results year-wise and bank-wise, right? ये देख पा रहे हैं आप लोग? Can you see it? 2003, and then it's quite possible that your guide may ask you, Memo sir may ask you to change the format of this, right? So for that, just double click it on the pivot tray. इस पे click करना है आपको. It will open like this. So now you have this, convenience of changing the format, right? You want to keep statistics on this side. Moment you keep put it here, you'll see the format is changing. Variables को इधर रखना चाह रहे हैं आप. Again the format would change, and type you want to keep it here. Again the format would change. So at the ease of your click of a mouse, you can change the format, right? Or in case you want to represent this data in an online presentation, you want to use scroll down option. So here you have this button where when you do it, you'll see the scroll down. Year wise you can have data, right? This will change with scroll down option. Or you want to do it for type of bank, scroll down. The another option, you can have two possibilities of 99, then private bank, 2000, then foreign bank, then 2001, and then private bank. All these results. So as per your convenience, with the pivot tray, you can arrange your results, right? So you will have results like this. Any query till now? Is it useful? Are you finding any value in this?
Definitely.
Okay. Let's move further, and let's have a look at some of the more learning. So this I think all this you are aware of. For skewness, kurtosis you are aware of, I'm sure. And we can go for summarization. We have tried to do that. I think binning of variable would be useful here. At times what you do is you take data into different groups, whether it is in terms of age or it is in terms of salary. So my suggestion would be, rather than taking data in terms of groups, you should take data as it is. The data could be available. That will give you more information. So for that, maybe we can open a file, another file, say job satisfaction, right? यहाँ पे एक फाइल है job satisfaction. So this is a file, right? Here is the file of job satisfaction of employees. So when you ask someone about their salary or age, it's possible that you make groups, whether your salary is up to 50,000 or 50,000 to 1 lakh or 1 lakh to 1.5 lakhs or 1.5 lakhs to 2 lakhs. Which will be, in groups. You won't be able to have the exact average salary, right? Because if these are groups, you cannot calculate the average, right? So better idea is whether this is age. If it is numerical data, because salary is a ratio data, numerical data, we should avoid the first instance itself of going for groups. It's better to have the value as it is, right? Grouping can be done later on. So now we'll try to learn that grouping or binning. So under that, what we are going to do here, in SPSS, those possibilities are there. So under data or under transform, yeah, you have this visual binning. Okay, if we have visual binning, और visual binning हमें salary की करनी है, current salary. If you click it and transfer current salary and say continue. When you do that, you will see these are, you know, the data distribution information, and for making bins, you have these possibilities. One is you can give the exact value of cut points. Second is, suppose for the whole data you want to divide this into 4 equal bins, 25%, 25%, 25%. If we have, say, 500 respondents, around 100 each or 125 each, it should be divided. That is one possibility. And another possibility is you can have, with the help of standard deviation, a plus minus 1 standard deviation, which we discuss in normal distribution. So you'll have 68% का कैसे cutoff बनेगा, the lowest most less than 1%, then 0 to 1 33%, minus 1 to 0 again 33%, 66 ये हो गया, and the other side would be approximately how much, 34%, ना 17% each, right? So plus minus 1 sigma से वो आपके पास cutoffs आ जाएंगे. But before, probably to begin with, we can have these equal width cutoffs, right? When you do that, you'll see these lines will pop up, right? And you have these values. So first interval is going to be up to 26, 24, 600, and then 32. अब चाहे तो इसको थोड़ा, अगर आपको लगता है और वैल्यू बढ़ानी चाहिए, पकड़ के इसको इधर कर सकते हैं. At your convenience, you can change it. And this should be here. You can change it with your mouse or cursor, right? कि हमें यहाँ तक लेना 32,400 होना चाहिए. So you can change it till that particular value, right? And then make cutoffs. Cutoffs हमने already बना लिए हैं. Make labels. The moment you say make labels, it will create labels for you that these values are less than 23,400. Next set of values are from 23,400 to 32,994, 32,995 to 39,844, and then highest is 39,845 plus. Okay, and then before you click OK, you say binning variable would be salary bin, right? So because it doesn't take space in between, salary bin. If you say OK, this will create one variable for you. So you'll see here that this variable is created, salary bin, right? So this is the binning that has taken. So it's possible कि आप जो starting में groups बना रहे हैं, so which is better, making groups at the initial level itself or making at later stage? What do you think? Where you'll get more information? Hello? Where do you think you'll have more information? Initial level or later? Can you hear me? आवाज आ रही है?
Yes, sir. Later level, we will have more information.
Very good, very good. So binning later, because initially, now for this data, now you can have your average, you can have standard deviation, mean, median. So if you do the binning later on, you'll have more information. Because if you do it initial itself, which group you belong to, you won't be having the average also, right? So these are the bins created. Any query till now? Any specific area where you think I should focus upon in another 10-15 minutes? We have seen here descriptives की बात की है मैंने केवल for categorical data and numeric data. Descriptive is a univariate information, right? And then within that univariate, so let's try to try to analyze some results also. हमने जो ये univariate देखा है यहाँ पे, this is important, skewness and kurtosis, right? Skewness is related to data whether this is normal or not, right? So for normality, mean, mode, median are expected to be equal, but practically that may not be equal all the time. So what is that range within which your data would be assumed as normal, right? So various researches says if your results are within -1 to 1, the data would be considered as, इस slide को देखते हैं हम लोग. This is for normal plus -1 to limits. So if your skewness is between -1 to 1, यहाँ कुछ लिखा हुआ है इन्होंने, skewness is between, लिखा है हाँ, approximately normal if skewness is between -1 to 1, right? And more than 1, this would be positively skewed. Less than 1, -1, this would be negatively skewed, right? So, and for kurtosis, for normal kurtosis is expected to be around 3. So you may, interpret that. So see, CDR, cash deposit ratio, is minus 0.985 is assumed to be normal. Net interest margin is assumed to be normal, whereas return on equity is negative, minus 3 point something. This is negatively skewed or left tail skewed. Cost of deposit, cost of borrowing is positively skewed. Borrowing per employee is positively skewed, and profit per employee is negatively skewed. ये clear है सभी को? So these are not normal. Anything less than -1 or more than 1 is not normal. So it won't follow normality. It would not be a normal distribution. So you may have to apply, some other distribution. You may have to identify and look into it, right? Then we can say take correlation, bivariate. So in the analyze, you have this option of correlation, bivariate correlation. So you want to see correlation between current salary and beginner's salary. So you have these 3 options here. You'll see Pearson correlation, Kendall-Stowe, and Spearman correlation. So you can have for scale data, this would be Pearson correlation. For nominal data, this would be Kendall-Stowe, and for rank data, this would be Spearman correlation. You click it OK. So you see this is the correlation. 0.867 is the correlation between these two. And p-value, I think all are aware of p-value. As anyone who's not aware of the p-value, this significant value is p-value. Less than 0.001 means results are significant. Correlation is not by chance. ये सभी को clear है नहीं? When you interpret the results, आपको कुछ ऐसा लगता है कि जो कि clear नहीं है, तो I can help you. This is p-value, right? Results are significant. Some memes यहाँ पे मैंने share किए हैं related to p-value. You may understand some of them, you might not understand some of them, but that's okay. p-value जरूर समझ में आना चाहिए आप लोगों को. The probability of the results to be, यहाँ से मैं बता भी सकता हूँ आपको, if I have that normal shape. Yes, suppose this is 5% or 3% or 1%. This 5% normal curve. What is the probability of your test statistic falling in this region? On the right side you have rejection region, and on the leftmost also side also you have rejection region, right? This in total is 5%. So it will fall in that region if your test statistic is less than 0.005. If it is less than 0.005, sorry 0.05, this would be in the rejection region. ये मालूम है आप लोगों को? Quickly, in case you want to ask me anything on this. So if you are okay with that, we can open another file. यहाँ पे regression cars, and this file is of data of various characteristics of a particular car: miles per gallon, engine displacement, horsepower, weight, acceleration, year of manufacturing, who is the manufacturer, number of cylinders, right? So to understand bivariate correlation better, we can have correlation among some variables at the same time. And this SPSS has a characteristic because correlation will show you the upper triangle as well as lower triangle. It's sufficient to have idea of lower triangle, and diagonal would be nothing but the coefficient of the variable with itself, which always be 1. तो उसको आप चाहें तो रहने भी दे सकते हैं. Okay, when you do that, you have these results. We are now reaching the bivariate analysis. So if there is a correlation, there is quite tendency of some kind of relationship exists. So under that you have engine displacement with miles per gallon. That means if engine displacement goes up, so miles per gallon कम होना चाहिए, बढ़ना चाहिए. Engine displacement, if you understand, cubic centimeter में कुछ रहता है, cc में ये. Engine displacement of nano car versus Harrier, right? तो माइलेज किसकी कम होगी, नैनो की कम होगी या हैरियर की कम होगी? हैरियर की माइलेज कम होगी ना, नैनो की तो ज्यादा होगी. और यू कैन से मारुति 800 वर्सेस किजाशी और ब्रीजा, हॉर्स पावर वर्सेस माइल्स पर गैलन, देयर इज नेगेटिव कोरिलेशन. व्हीकल वेट जैसे जैसे बढ़ता जाएगा माइल्स पर गैलन कम होता जाएगा. ये क्लियर है सभी को? This is how you can try to interpret correlation, right? There is negative correlation, and if it is, we know correlation lies between -1 to 1. If it is on the negative side, it's negative. If it is, you may note down, more than 0.7 or less than -0.7, this is considered as high positive or high negative correlation. Between 0.4 to 0.7 is considered as moderate, and less than 0.4 is considered as low correlation. So you may write low positive, low negative, and moderate correlation, right? So these can be reported with p values. In this case, in most of the cases, it is significant, right? So this is how a correlation can be calculated and reported, right? And quickly, finally, I think we can export all these results to a file. It is say I want to locate it at my desktop. Say this is data handling. जो भी results निकाले गए हैं आज Feb 2nd नहीं, Feb 10th, right? So if I save it, and you have some options here, what you want to keep, how you want to keep, options that you can check, and what document, say okay. All these results would be exported to a file, and once we have these results, this file would be visible on my desktop. Data handling February 10th. Here's the file. So these are some results. So here's your box plot. आप उसके चाहे नीचे लिख सकते हैं आप interpretation. How do you write interpretation? And wherever you need, जिस भी फाइल में आपको ट्रांसफर करना है उसमें वहाँ ट्रांसफर कर लीजिए. This would be useful. जो नहीं चाहिए एक्स्ट्रा चीजें हैं उनको आप डिलीट कर दीजिए, right? Don't need it. Another interpretation can be here. So this is ready for reporting in your thesis or paper, जहाँ भी चाहें आप इसको report कर सकते हैं. Some statistics, some results, summary अगर आपकी duplicate अगर आप use करना चाह रहे हैं, or you want to use for different years, what is your interpretation, then whatever is your interpretation, those can be reported. So all those tables, whatever we have done the analysis with the help of SPSS would be available here, right? So because I have a meeting at 12:30, I shared with Harshita, so I would like to stop here.